All right, so before starting our class, let me share my slide. So only few students are there. Maybe many of you are traveling today's class. I mean, many of you are traveling to come for the physical presence on the campus. So anyway, that's a good thing. Although only few are there, we'll still have the class, because today's class will just discuss about few fundamentals that many of you are already aware of, and many of you, although not there, still you'll be able to understand them just by going through the slides. So, but before discussing many things about operating system, we should have a brief idea about few fundamental concepts that we are going to discuss on today's class. Okay, so let me share my slide and we'll start today's class. Can you able to see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
So today we'll discuss simply a basics of computers. Before discussing our class, so this course on data structures and operating systems for you guys, I will show you the syllabus. First, the curriculum that has been given from your respective department. This is the curriculum that we are going to cover, that has been asked us to cover. So we'll start with the unit 1, basics of computer architecture. What is hardware software components? What is actually CPU, ALU, memory, input output devices? What is system software, application software? All these things we'll try to discuss and have a few details what they actually are. We'll try to discuss them, and further we'll discuss what is our operating system, what is its role, how it manages, what is the main purpose, how it is related to hardware. All these things also we'll discuss in the subsequent classes. So we'll also see that what is a programming software, what is a process, what are how to calculate time and space complexity of programs. Also we'll try to understand. And you got here a unit 4 exclusively on data structures. So what is need for data structures? What is a non-linear or linear data structures? What is stack queue, tree, graph, B tree? All these concepts also will discuss in the part of unit 4. And unit 5 extensively or exclusively in operating system concepts, like how on memory, processor and memory management, process management, concurrent process, scheduling, preemptive, non-preemptive. All these things we'll try to discuss, which are very important concepts of operating system that we'll discuss. But if you see your lab assignments are exclusively they asked or designed based on the concept of data structures. So already you might have started your assignments on data structures. So all the assignments you will get using, in your assignments would be on data structures. So we will try to carry out the assignments, and if you are facing any difficulty in implementing or in understanding the concepts, perhaps we can discuss the data structures concept first, then we'll come to the operating system concepts subsequently. I'll take the feedback from your guest faculty. I asked them to give a brief idea about the concepts that we are going to discuss, which will help you to implement. I guess they are doing it, and I guess you are comfortable in implementing as well. So, or you can let me know, like if you want to change or if you want to discuss data structures first, then subsequently the operating systems also we can do that. That's not a problem. So maybe we'll observe like 2-3 weeks and we'll get a feedback, and based on that we'll decide how we'll proceed further. Okay, so these are the few concepts that we are going to study in this semester for this course. By the end of this course you will be having many of you, all of you will have an idea about all these words, what they are actually are. These are the prescribed textbooks, Fundamentals of Data Structures by Horowitz and Sahani. This is a good book. Data Structures Using C by Tenenbaum is also a good book. And Operating Systems Concept by Abraham Silberskatch and Peter Galvin. This is an important must book. If you have a habit of buying books, please buy this Operating System Concepts and Abraham Silberskatch. The recent edition is 10th edition. You buy the 10th edition Operating System Concepts. Many of the things that what we are going to discuss in class relevant to operating systems, I'll be referring from this book only. Okay. So also the same book, when I studied my BTech in computer science, I studied the same book by the same authors. But the problem, I mean, like the difference is when I studied like in 2007 to 11, which was like a decade back. At that time, many things were not sophisticated as now what we are seeing. For example, on those days, Android operating system or iOS operating system, they are not that familiar. Okay, predominantly even Windows 10, Windows 7 is also not came into the picture. At the time, we were using Windows XP, Windows Vista, which are very old operating systems which we are using. But in this one decade, means like in this 10 years, the things evolved or changed predominantly. The operating system concepts of 10th edition will cover the will consider the recent inventions or recent technologies, how an operating system works with respect to various platforms that has been discussed in this book. That's why I'm asking you to buy the recent edition, but the fundamental concepts will be the same, more or less it will be the same. But if you are to have a better understanding by the recent 10th edition of operating system concepts. So these are the few things we would like to tell from the basics. But today's class is basics about computers only. Many of you are aware of what actually they are, but we'll try to understand just briefly. We'll go through that because this is the beginning class. So we'll try to carry forward. So we all know that nowadays we are most familiar with mobile computer because using smartphone you can call and you can I don't know how many of you are in this class also you are listening to your mobile or through tablet or through laptop. So this is mobile computers predominantly has been used by many persons nowadays. So it's a mobile, you can carry it anywhere. You can put it in your bag and take it anywhere, right? So this is a mobile computer. We are predominantly using such smart gadgets, right? So in these days, everybody is using at least these two devices will have a smartphone and a laptop. All of you will have, I guess, maybe tablet. Few of you might have, or few of you may not have. But predominantly, many of you are using mobile computers. But the next phase is microcomputer. Microcomputer is not a mobile, which is a static, which you will keep and fix at a particular place. If you have to use that, yeah, excuse me, you have to come to that particular place. For example, the class that I'm taking now from my office is a microcomputer. Like what I'm sharing my slide is from my office is a microcomputer. Which has a system unit that I'll discuss. You have a monitor. I'm sharing the screen. I'm not using a mobile computer, which is not a portable. So we can do that. We can do that. Perhaps all of your join through your mobile computer, through phones or through laptops, so on and so forth. But a microcomputer is also similar way of working computer, but in a static way. You can fix at one place and you can come and work at that particular place. So this is a simple desktop where a personal computer, we can call that as also the personal computer or a workstation. Workstation is simply little having more higher capacity than a personal desktop. You'll have better graphics card, you have a better processing speed, you have better storage capabilities. So it's a simple better than a desktop, right? So so this is a simple idea of microcomputer. You have a mainframe computer. So this the mainframe computer will look like this. So you got see the servers are connected from one place to other place. There are so many servers. There are so many processors. There are so many servers. They are connected, and the mainframe computer is predominantly where we use in our college institutions or data centers. You can call that as also data centers where we store the data and process and analyze, right? So this is also one type of computer, mainframe computer, where we need to store a lot of processing. You should have a lot of processing capabilities. For example, in your class there are 1,000 students from your course. All of you came for physical registration, and you could have done for enrolling a particular course or for counseling. All these things, many thousands of students will come and do it at a particular instant of time. So your personal computer or workstation will be not capable of processing all those details in a given time. Even though if you want to do that, it will take more time. But if you want to do that, you'll have to do that faster way, where mainframe computers will come. Since you are not there in the first year, perhaps if you come to a college computer center on the ground floor, you'll be able to see a mainframe computer that will be accessible. I mean, like that will provide internet for our whole campus, and also for the dean of academics for storing and analyzing your marks, grades, transcripts, and also for admission details, registration details for each and every student. What is the course? If they got failed, what course they have to, when they have to, when will the supplementary exam they cleared. All these details, a single computer, single mainframe or workstation will not be sufficient. So for such cases, you will go for a mainframe computer with more processing capabilities, more storage capabilities. It's better to maintain a big institution, right? So in such cases, we can go for mainframe computers. So you got beyond that a supercomputer. A supercomputer will look like this. Even a mainframe will have just maybe like 4 or 5. You can see that here hardly you got maybe one row, but a supercomputer you got multiple rows, and also the supercomputer is even more powerful than mainframe computers. Even it had more processing capabilities. Even it will have more storage capabilities. So when an Avatar movie or a graphical VFX movies they made with high quality graphics, with high quality uh, pictures, you'll be not able to process them in a simple machines that we are having now. So they need a lot of graphics. They will be designing all those movies. They will be capturing all those movies in processing like all these graphics, which will take a lot of memory, which will take a lot of processing speed, which will take a lot of storage. So that will be not possible as simple that we are using now. So we need a supercomputer to carry out such kind of big tasks. So all the videos that you capture, you design in a graphical graphics will consume a lot of memory. Perhaps the Avatar movie, when they captured the original picture, would have not less than like 200 GB or 100 GB like that. Okay, but they compress that image, they compress that movie without losing the quality. You will be able to still see a good quality image for 2 GB or 1 GB, but the actual image when they capture it will be more than like 20 GB, 30 GB like that. So you have to process such kind of a huge data within the given time. So for that they use supercomputers to carry out the task. Otherwise, it will hang, it will delay. A lot of issues will be there. So not only that, and supercomputers are also used for many other applications like satellite launching and in space images when they capture to process them. So there are so many satellite images. Most of them they are processed using supercomputers, right? So there are many various applications where the application demands a better quality processing speed capabilities. You'll use a supercomputer at this place. So this is just idea about various computers. You have a mobile computer, you have a mainframe, you have a supercomputer, you have various categories of computers, just to have an idea. But when I say computer, you can divide them into two parts. One is hardware and software. So in subsequent slides, we'll try to understand what are the various types of hardware and what are the various types of software, and we'll try to conclude this class in few minutes. Okay, so please pay attention. So let us now try to take what is hardware and software. So when I say hardware in a computer parts, you got system unit, you got input devices, you got output devices, you got storage devices, right? So we will try to see what is system unit, what is input devices, what is output devices, what actually are storage devices. So we'll try to understand. Likewise, when we say software, in software we'll try to understand, like, there are three important things that we need to understand from computer point of view. There is operating system, there is an application software, there is an utility software. So they all are different. We will try to understand what they are in the subsequent slides. Okay, so let us start with hardware. So with the system unit, the system unit will look like this. If you open a system unit, for example, if you open this is a system unit, and this is called a system unit. So if you open this slide, if you open this box, it will look like this. It will look more or less like this. So you got power supply, you got power cables, you got CD or DVD ROM. This entire so you got a hard disk, you keep hard disk here to store. This is also called secondary storage. We'll discuss that in detail in the upcoming slides. You got a floppy disk drive, you got data cables, motherboard, battery, you got input output device, you got RAM, you got CPU and fan, central processing unit and fan and a case fan. So all these things you will keep in a system unit. All these things is called system unit. All these things you will keep in a box which is called a case. Okay, the box that you keep inside all these things, we call that as a case. So this is when I say system unit, these all things will cover. So we'll try to see that in system unit you got a motherboard, you got processor, you got RAM, you got a case that you keep everything inside it, you got a power supply, you got a floppy drive, you got a CD or DVD drive, you got hard drive, which is a hard disk like secondary storage, you got video card, sound card, and modem. So we'll try to see what they are, how it look like in the coming case. So case is a frame that holds the motherboard or power supply or disk drives, adapters, any other physical components of the system. This is the case which I am using now to take your class. The same case, Dell Optiplex. This is the case what I am using. The machine that I am using now to take this class. So this is where inside that you will got a motherboard, you will got power supply, you got disk drives, everything will be embedded inside that. So this the case is a box or a frame that will be helpful to place all the rest of the hardware or rest of the physical components. This we call that as a case. So a motherboard will look like this. This is also called as a main board or a system board and a planner. So in motherboard, you got a processor. This is a processor where you will execute your instructions. You got RAM here. This is a RAM slot where you will keep your RAMs. So you can see that there are various inputs output devices you can connect. You can connect monitor through this VGA cable. So you got LAN port here. You can connect LAN or USB ports. I think this is LAN port and this is USB port. So you got all this connects. All the components will be connected to motherboard. So the motherboard connects all the components inside the computer case. So this is also called a main board, which is very important. We got a processor. So processor is also called as a brain of a computer or engine of a computer, where it will execute your instructions. This is also called as CPU, central processing unit. Okay, that we all aware of. From many classes we have studied, right? So this is not a new thing. When initially a computer designed, this central processing unit took a space of a whole big room. But thanks to the technology and especially VLSI, very large scale integrated circuits, made the processor so compact it will look like a very small gadget, right? It's a small device. So you got two types of process, Intel and AMD. There are many versions also in Intel and AMD. For example, we will also try to understand in the subsequent classes. Excuse me. What is i3, what is i5, what is i7, what is the recent processor is i9 also came into the market. We'll try to see what the differences between among them in the subsequent classes. But the processor is where each and every instruction is executed, and it is the engine or brain of the computer. If processor is not working, then you will never able to execute any instructions. So you got a memory. Memory is also called as RAM. So it's also called as primary memory. The primary memory, RAM, is also called as random access memory. We call that as a system memory. Okay, so the system memory is often called as RAM, also random access memory. This is a primary memory which holds all the program's data that the processor is using at a given time. So if a processor wants to execute some instructions, it will look into the RAM and it will keep executing the instructions by looking in the RAM. But RAM is a volatile memory. It will not have a permanent storage of the data till as long as the power works. So it will be there. If the power goes off, then again it will start from secondary storage. It will fetch the data from secondary storage to RAM. From RAM, the processor will take the instructions and it will execute. Okay, so the RAM, if it is more, then the speed of your computer will be more, because you got a lot of space to execute the instructions. Otherwise, you have to keep swapping the old instructions and you have to keep inserting the new instructions within the given space. Then it will take a lot of time, right? So likewise, you got a power supply. A power supply device will look like this. So electrical power supply, which is a single part of the PC, which will look like this, right? So you got a CVD or DVD drive, which is a compact disk or digital versatile disk, which is having a relatively high capacity, which is the remote media and drive optical drives also. So many recent systems which comes with rewritable CD DVD with a combined DVD-ROM, right? So this is the CD which you can write or read the data. This is CD DVD drive, which will help this device to work in a proper way. So this is, if you see this slide, you keep CD DVD drive here, right? CD DVD drive here, you keep hard disk here. So if you press, you can see here in this also, this is CD DVD drive. You press this button, it will come out. So you can put your CD and you can press it back and it will start processing, reading the data or writing the data. So this is a hard drive. This is an internal hard drive. It's a primary archival storage memory of the system. This is also called a secondary storage. You got here, see, 100,000 GB. 1000 GB means approximately 1 TB. So 1 TB is a good space, like 1 terabyte of storage you can able to preserve, right? So you got hard disk, two cables will come. One is data cable, one is power cable. Power cable will give its power supply, and data cable will help you to read or write the data so that it will be stored or deleted. We can decide what to do and how to do, right? So this is the hard drive, which will look like this. Also, you have video card. If you want to have graphics with good animation to play some games, you need good graphics. So the video card will help you will enable you to get a more sort of better video quality. So a video card will look like this. So it will help you to control what you are going to see in the monitor. Likewise, you got a sound card. It enables the PC to generate complex sounds. That also will look like this. So a modem or network card will look like this. It will help you connect to the internet. This modem, which is a portable or which is not a portable, this is also called as router. So these two devices will help you to connect or to the network or to the internet. So if you come to your hostels you could see that each one will give you a LAN port. You can connect through the LAN, or there will be a Wi-Fi. You can connect to the Wi-Fi. You can connect your laptops and mobiles through that Wi-Fi. Or you got a modem also, which is portable. You can just plug and play, which can have the internet via modem also. So these are the few things that we need to aware of system unit, and there are few things about input devices we'll see. So any peripheral, any computer hardware equipment used to provide data, control a signal to the computer, we call that as an input device. So allows the user to put the data into the computer. For example, keyboard. So the data what you're seeing in the slide, which did not come an accident, right? I have typed word by word, letter by letter, I have typed. So you can able to see the words because I typed in the keyboard. And you can see the laser point which is moving with the red color. I'm trying to do some action from my hand by moving the mouse. The same where which direction which I'm moving the mouse, the laser is also moving. So what I'm trying to do is, like, I'm trying to provide some data or control signals to the computer externally from outside to the computer, which will act as the input devices. For example, keyboard, mouse, touch screen, scanner, and webcam. So we all know how keyboard and mouse looks like. The scanner will help you to scan the image, files, documents, photos, and so on and so forth, right? So you got a touch screen. You touch at a particular place, saying that this is the application you are interested in. So that will consider as an input to the computer, and it will act accordingly. That it will do and process accordingly, right? So many of you might be using your mobile phones, smartphones. You are touching at a particular place. On the background you might be seeing some icons, images, but the moment you touch it, the application will launch, taking that as an input, right? So these are the few input devices. Likewise, there are few output devices. Any computer or any piece of computer hardware which you use to communicate the results of processing carried out by a computer to the outside world, we can call that as a output device. So for example, what I am moving my mouse in a laser pointer, which are executed by the processor, but we will be able to see what exactly happening using a monitor. I'm projecting, I'm able to see that my screen is visible, and I'm able to move my mouse instructions that have been processed, and I'm able to see visually because of the monitor, so which is an output device. Printer will take output device. Speakers, the sound will come, which is an output device. Projector will try to project something on the screen. They are all considered as an output device. Okay, so a monitor will look like this, a printer and a projector and speakers will look like this. Either you connect through a Bluetooth or through a wire. So these are output devices. So you got some storage devices, any computer components or devices which will record the media, which will be able to capable of storing them. We call them as a storage devices. You got various examples of storage device. You got floppy disk, you got hard disk, you got pen drive, you got optical disk. So we'll try to see what they are. So floppy disk will look like this. This is a floppy disk. This is a floppy disk reader or writer. You inside this floppy disk, inside this reader or writer, you'll be able to read or write the documents. It is a portable, but the capacity is very less. It is just 1.44 MB only. So in olden days, when the computer was invented, to make something portable, they were predominantly using floppy disk. Predominantly, they are using only files to store the data. So, which is very less capacity. But if you want to use the floppy disk, you need to write disk drive or reader or writer. So further, it is evolved to a better utilization of space. You got an optical disk from floppy disk because the capacity is very less. The technology improved and we went for an optical disk. Optical disk, we got three types, depends on the capacity. You got a CD, which will come with 650 MB. You got a DVD, which will be 4.7 MB. You got a Blu-ray disc, even with 25 GB. So this is also portable, you can carry it anywhere, but in order to read or write on optical disk, you need an optical disk driver, which will look like this. So this part is called the optical disk, and the reader, when you insert inside, which will be looking like optical disk writer and reader. Okay, so further it is evolved to USB flash drive, but nowadays floppy disk nobody is using. CD-ROM very occasionally, very seldom, very less people are using, but USB flash drive is another storage device. You got a capacity minimum from 8 GB to maximum to 1 terabyte, which is a portable. You don't need an external device, reader or writer to do that. So USB flash drive will look like this, and it is predominantly used by many of us. Even I believe that each of you we might have your own USB flash drive to store or copy the data, right? So this is no need to tell to anyone. So this one kind of storage device. You got other storage devices like hard disk, which is an internal connected to your personal computer. So that capacity is also vary from 100 GB to 1 TB, which is not portable, because if you have to take that, then you have to take the entire computer. You got an external hard disk. The external hard disk is from 1 TB to 16 TB, that we all know, which is a portable, which will look like this. So you can store the data, and if your system is not having sufficient memory, you can use external hard disk to store the data. You can store your data and information in cloud also using Google Drives, Dropbox, OneDrive, and so on and so forth, right? But they can also be considered storage device, but they will be not the scope of your syllabus, because we will try to see each cloud again. It's a huge topic to discuss about their hardware and processor and so on and so forth. So, but you can store the data in Google Drive and Dropbox, which is good, but still that is not alone sufficient, right? So you got a Google Drive and Dropbox, so which will help you to store the data. From the storage point of view, I'm just giving an information. But however, when you talk about hardware, you consider only internal hard disk and external hard disk. So before going into computer software, if you have any doubts so far in the computer hardware, you please let me know. Okay, I will give a small 2 minutes break. You let me know if you have any doubt. Okay, nobody is raising any questions. So we'll continue our class, and if you have still any questions, I will take at the end of the class. Okay, so I guess what we are trying to discuss, what we are discussing, is it making sense to you? Are you able to understand?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, so let us go ahead now. So a computer software is a collection of programs, computer programs, procedures and documentation that performs different tasks on a computer. So few examples are operating system, application software and utility software, that you already know that you have written computer programs in your first year C programming, but those programs are designed to have a simple assignments and simple application. But when it comes to software, the software is a set of a set of programs, not only programs but also with procedures and documentation that performs different tasks. Okay, the software is a collection of programs, procedures with a clear documentation how the things will work out. So, for example, your operating system, it's a software, but software inside that you've got a lot of programs to carry out each task, how the things will be performing, right? Yeah, again, likewise, then application software, utility software, they are different from operating system. We'll try to understand what difference they are and what how they are different from each other. We'll try to see them. So, an operating system is a manager. It's a software. First of all, it's a software. It's a collection of software that manages the computer hardware. So you got a hardware, you got a human, but you will be not able to control the hardware as we wanted. But there need to be a software inside to manage the computer hardware resources to provide a common services for the computer programs is what actually the operating system is. But this is not accurate definition. There is no perfect definition, but we can define the operating system more accurately. That we will discuss in the next class. Okay, more detailed, accurate definition I will give you in the next class. But just for an understanding, what actually an operating system is, it is a software that manages the computer hardware resources to provide services. Okay, you can remember up to that point. For example, I want to project some slides. Now what we are using an operating system is Windows 10, right? There are various operating system, which is an operating system is a vital component of a system software in the computer system. There are various operating systems. You got Windows operating system, you got Linux, you got Mac OS. Those who are using Apple computers or Apple laptops, Apple phones, they are using Mac OS operating system. You got an Android operating system. Many of you might be listening through your mobile devices. Most of you, all of you, I don't think you'll be using iPhones only. Many of you might be using other mobile devices, which predominantly depends on Android operating system, right? So they are all operating systems. You got memory, you got RAM, you got speed, you got camera, you got many devices. How they will be handled, who will handle all of them, is where the operating system will come into the picture. Okay, so for example, I'm just trying to take a class from online using a computer. So this Windows 10 operating system, the Windows 10 operating system that we are using now, see, I will show you this. So the operating system that I am using now is a Windows operating system. So you can see the details about what is the version that I am using just by clicking the properties. You can see that I'm using Windows 10 Pro. Okay, this is the edition that I'm using, Windows 10 operating system Pro, which works with with version 20H2. Okay, so this is installed when it is built. So I got 4 GB RAM. My processor is i7 Intel Core i7 processor with the processing speed 3.4 gigahertz, right? So it's a 64-bit operating system. What is 64-bit operating system? That we'll all discuss in the subsequent class. But so the Windows 10 operating system will help me is taking class. So it has an way of providing an interface, so graphical user interface, which is good. So I'm able to take the class using Windows 10 operating system, although I have a hardware which will help me to enable many other parameters, right? So some of you may be using Linux. If you are using mobile, you might be come across Android operating system to design some applications. Likewise, if you have run your C programming in your first year, you could have run using a command gcc space program name .c, and when you execute it /a.out, those are the command instructions that you are giving, which use a command line interface, which is not a graphical interface but a command line interface. You are executing still the work what you want to do using, which is a different way of taking the things. That's the Linux operating system. If you do use some other C or C++ like Dev C++ to run your program, which has a graphical user interface, you just go to a particular place, start, run, you play, it will automatically run and execute the code, right? So there are different types of operating systems, the graphical user interface, but basically how we are handling the hardware. Suppose when I'm writing a code, when I'm writing a C programming, so those instructions will be stored initially in your secondary storage, right? It will be saved. Once you save, it will be stored in secondary storage, and when you want to run, it will go fetch data from secondary storage to primary storage, and primary storage it will go to the processor, and when the processor is trying to understand your instructions, if there are no errors, then it will execute and give you the output you can able to see the output in a monitor, and if there are any errors, it will show that there are some bugs, you have to fix them to see the output. You'll be able to see all these things, right? Who does that? Taking the code from your secondary memory to primary memory to the processor, and it will show the output. Who does all this job on the background is what actually the operating system will handle all these things. Okay, operating system will handle all the background, how the process is created, how the process is executed, how the process terminated. All these things will be taken care by how much storage you needed, what RAM is, how much RAM space is needed, what are the other input output devices needed. All these things. For example, you write scanf, then a computer will expect some input from you, then you have to type something from the keyboard, it will expect, right? So there as an input output handler you are creating. So all these things will be handled by operating system. So there are various versions. So Windows is not an open source, Linux is an open source. You can just download, and I will recommend for all the computer students to work on Linux, but electronic students, if you work in Linux, that will be good. It will help you to understand how the operating system works on the background. You can develop your own code and improve that. That is possible in Linux, which is an open source, but Windows is not an open source. We don't know how the code is running on the background, which programming language they developed on the background. We have no idea, right? We can't improve that. So this is a simple idea of operating system. So there is an application software. Application software is different than operating system. So application software is also known as application or an app in a computer, which is a computer software designed to perform specific tasks. For example, I am presenting this slide using Microsoft PowerPoint. So PowerPoint is provided by Microsoft software. So this Office, Microsoft Office I installed. I'm using this PowerPoint to share the contents that I want to convey in your class, right? So this is an application. Likewise, you can use if I want to draw something, if you want to paint, if you want to do some graphics, you can have a graphics editor. Or I want to do some data analysis, I want to store data and see, you can use spreadsheet, you can have a presentation software, you get video games. They're all not an operating system, but on the top of it, to perform certain tasks, we will use them, we will install them and we'll use them. You want to play some video, you install VLC media player, which is an application software, right? So this is not an operating system, but there are some softwares designed for a particular application. Likewise, if you are using, if you are attending the class through MS Teams, you would have installed in your mobile an app, MS Team app. You click there and it will give an interface to attend this class. So which is an application. So there are different applications which we can call them as an application software. But beyond that, there is an utility software. Utility software is designed to help and analyze or configure or maintain a computer. For example, antivirus. So some virus may be attacking my system, and I want to protect my computer and analyze where are the somebody stealing some data, or I want to configure and I want to optimize. I can install an antivirus, which is not a specific application that I'm trying to take advantage of, which is not an operating system also, but I'm utilizing that software in order to improve my performance, in order to protect, not improve, right? So this antivirus is one sort of utility software. For example, disk defragmentation, screensaver, disk cleaner, file manager, all these things are utility software. You can do the disk defragmentation using simply like this, right? You can go to manage, you can go to the storage, you can see that disk management, disk defragmentation, all these things. I can see, for example, C drive I got 75 GB and F drive I got 335 GB. I can shrink this volume, say 150 GB, then I'll 200 GB will be left, and I can create a new volume out of it, new drive I can create, and so on and so forth. Okay, so 260 MB is unallocated. This is a primary partition or extended partition, free space. All these things we can able to easily see them, right? So you can defragment it, or you can carry out a number of actions. So this is a simple way of just telling you, but you can understand that you'll be able to difference. Operating system is different, application software is different, and utility software is entirely different. So this is like Windows Defender, or you can also see here, like it will be there here, Windows security, like virus and threat protection. You can update what are the virus and threat protection. This is nowadays coming with along with operating system, but if you go for Linux or some other operating systems, which may not be exclusive. Windows 10 nowadays, or Windows 11 in the coming days, they are all coming as a inbuilt features of operating system, but in it's not necessarily. So operating system main job is to handle your hardware, input output devices, or your system unit devices, how you're taking and control when a signal is generated from your mouse or keyboard to a processor to monitor how you are projecting. Predominantly the main focus of an operating system is to handle the hardware, but nowadays they also be part of the operating system, but you can install an antivirus exclusively, okay, on separately to protect your system, right? So these are the various softwares that are considered that as a utility software. So I guess you have a brief difference, having a difference between all these three: operating system, application software, and utility software. If you have any doubt so far, you please ask. Again, I'm asking you that if you have any doubts so far in this class, you can please ask.
Hello, sir.
Yes.
Sir, in the initial slides where you were explaining the input output devices, so can a USB port be input as well as output device, because input and transfer both takes place through that?
USB port.
Yes, sir.
USB port will come as a part of system unit motherboard. So you got here CUA. This will come as you plug and play. That will come as a part of motherboard.
So it cannot be considered as a input device or output device, sir.
No, no, you cannot consider that as input device or output device.
Okay, sir.
USB device itself, you can consider that as storage device. Predominantly, you are using USB to store the data, right? Where you are inserting, it's considered as a part of motherboard. The interface that you are providing, that is not an input output device. Likewise, where this storage devices are different than input devices and output devices, okay? So storage devices, where you store the data, how you store the data, they are different than input and output devices. So that's why I'm telling you, input devices, output devices, storage devices, they are all different. Is this clear?
Yes, sir. Fine.
Okay. So if you understood the class, let's do a simple exercise. I will show some components, identify them. Okay, that based on the class that we discussed now. Can you tell me what is this?
A motherboard.
Is this correct?
Yes, sir.
Yes, sir.
Motherboard.
Okay. So what about this?
Sir, power supply.
Okay.
RAM.
RAM.
Okay.
RAM.
Processor.
Processor.
Processor. or
Processor.
CPU.
Floppy disk.
Floppy.
Floppy disk.
Okay, good. I believe that all of you paid attention in today's class. So we'll stop here. We'll continue on Thursday's class. If you have any doubts, still you can ask me. I already shared the slide in your class. You can go to your class materials and check in the files. you will see a folder class materials. Inside the class materials, I shared already lecture 1 basics of computers PDF. We'll check whether you'll be able to access it or not. You'll be able to see the slide.
Yes, sir.
Yes,
All
sir.
right.
Lecture 1 basic of
Yes, sir.
Yeah. So you can go through the slides again. If you have any doubts, please you can fire away at any time. If you have any doubts in today's class, you can discuss. If you have no doubts, then we will stop today's class. We'll discuss again on Thursday.
Sir, will we do case studies in this course?
Maybe as a part of assignments, I'll give.
Okay.
Okay. Any other questions? Any other doubts? If there are no doubts, no questions, so we can stop here. We will continue from next Thursday, 3 to 5. So just go through briefly. People who are not able to attend the class also, it's not that difficult to understand today's class. You can just go through the slides. You'll be able to understand easily what we discussed. Okay, it's not that difficult. All right. So if there are no questions, we will leave. We will stop here. We will leave the meeting. We'll end the class.
Thank you, sir.